Hi there, and welcome to day 1 of Unit 11. We are going to talk about trigonometry graphs, and today we are focusing on how to graph the basics of sine and cosine using things like amplitude and midline. Alright, so what you're looking at right here is a sine graph. This is one of our trig graphs that are considered cyclic or periodic because there is a pattern of repeating y values at specific intervals. So, ultimately, this picture right here is actually just based on your unit circle. So where we have some space right here, I want us just to draw a nice little unit circle, which we know is a circle centered at the origin with a radius of 1. So that makes these coordinates 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, now based on what we also know about the unit circle is that each coordinate is a cosine of an angle and a sine of an angle. So specifically, we're going to look at the y coordinates. All right, so you are seeing 0, 1, 0, negative 1, 0, 1, 0, negative 1. And that's what's going to correspond on this graph over here. So at 0 degrees, you're seeing a y coordinate of 0. At 90 degrees, you're seeing a y coordinate of 1. At 180 degrees, we're back at 0. At 270 degrees, we're at negative 1, and then we finish at 360 degrees back at 0. So those are going to be the 5 major points I focus on a lot when graphing sine. Now, just to reiterate, I like to always show this little visual of how our sine graph is going to look. Okay, so here's my unit circle. Here is where I can take this and drag. And I'm specifically recording the y coordinate in the unit circle. So you can see at pi over 2 or 90 degrees, we're hitting a max of 1. We're back down here and hitting 0. Okay, now this is a y value of negative 1, which is why you're seeing a minimum. And then back at 0. So if I animate this, it'll just keep going over and over and over again. Now, like I mentioned, this is one of our trig graphs, which are considered cyclic or periodic because ultimately we just keep rotating round and round the unit circle, and that's how our sine graph comes about. Now, since this graph goes on forever in either direction, our domain is going to be all reals. But as you all saw, it was always oscillating or going back and forth between 1 and negative 1. So that's going to make our range. Okay, so in this table of values here, you guys are seeing some certain ones being highlighted, like the 0, 90, 180, 270, and 360. Those are the ones coming from my unit circle, so let's just kind of fill in this chart. So at 0 degrees, we were at 0. At 90 degrees, we were at 1. At 180, we're at 0. 270, we're at negative 1. And 360, we're back at 0. So like I said, these are the 5 major points that we're going to use to graph. Okay, so we're going to have to do our graphing ourselves now. So we're going to graph sine of x on the interval of 0 to 2 pi. So notice how we're graphing in terms of radians. Get comfortable graphing in terms of radians. Like I know we're very comfortable with degrees, but radians is where it's at when it comes to trig graphing. Now, the way we set this up is 3 boxes is going to equal pi over 2 radians. And we do that because that's 90 degrees, which makes it break up nicely into every one box is 30 for later things that we're going to do. So, in this direction, we're going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And I've just marked off 4 tick marks. So 12 total boxes here. This is pi over 2. And then technically this is 2 pi over 2, or just pi. So if you want to just call that pi, go for it. Which then makes this 3 pi over 2, or 270 degrees. And then this makes this 4 pi over 2, or 2 pi. Now, just so my graph is not tiny, I'm going to set my y-axis where every 2 boxes is 1. Okay, I'm going to switch up my pen color. So, at 0 degrees or 0 radians, we were at 0. At pi over 2, we're at 1, right from here. At pi, we're back at 0. At 3 pi over 2, we're at -1. And then we finish at 0 at 2 pi. And then I do a nice smooth curve through those points. It should not look mountainous or sharp like teeth. It also shouldn't look too super bubbly, because if it goes vertical, then it's technically not a function. So it's got to be somewhere sweet in between. So you got to make sure you have a nice smooth curve connecting those 5 dots. And that, my friends, is 1 cycle of sine of x, aka 1 rotation around our unit circle. Now, I can't help myself but get into some of the vocabulary here. So when we talk about 1 cycle of sine, that's called a period. So this is 1 period of our graph of sine of x. Now you'll notice that we're oscillating or going round and round this middle point here, right? This middle, which is your x-axis, that's called the midline. Oops, my thing shifted a little bit. Now the distance that we're traveling at most away from the midline, so like here, like this distance, or here when you're hitting that minimum, that's called the amplitude. So the amplitude is the distance from the midline. And since we're talking about a distance, distance is always going to be positive. So even though you're going 1 unit technically down here, your amplitude's still 1 because that's the distance at most you're traveling from the midline. Okay, so like I said, a little bit of vocab here when we come to graphing. That's your 1 cycle of sine of x. So hopefully you've labeled your picture appropriately. All right, now answering some questions here about the graph. In what quadrants is sine of x positive? Well, positive means it's above the x-axis. So if you look, we're positive or above the x-axis between 0 and pi. Okay, now let's think about that from a quadrant perspective. Again, this is 0, this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. Okay, 0 to pi is right here, which is quadrants 1 and 2. Now this should make sense because based on our ASTC chart, we know that sine is positive in both the first and second quadrant, which means it's negative in quadrants 2 and 3, which means it's dipping below the x-axis. And that's how visually that all ties together with your ASTC chart. So for negative, let's write down quadrant 3 and 4. As we saw, the maximum value of our sine of x was 1, and the minimum was -1. Now, as far as our intercepts go, you guys are seeing x-intercepts at 0, pi, and 2 pi, and our y-intercept on this graph is 0. All right. Let's go to the next page. All right, so formally defined, here's our midline. It's that horizontal line that's halfway between the max line and the minimum. The midline for sine of x, as we just saw, was the x-axis, or y equals 0. So like I said, if you do like a nice little sketch of sine here, that's your midline. Which makes sense, it's in the middle of the graph. Amplitude, I always informally think of as height. It's the height of the graph. So they're calling it half the distance between the max and the minimum values, and since it's a distance, it's always positive, so absolute value. The amplitude of sine of x is 1, because at most, that's how much we were traveling away from the midline. Now, we're going to graph sine again, but I'm going to add an amplitude to it other than 1. You'll notice I have now a 3 in front of it. That means instead of going between 1 and -1, we're going to go between 3 and -3. So it's going to become a taller graph. Now, you'll also notice in this problem, I've set a new interval. We're going to go from -2 pi to 2 pi. So let's set up our axes first. So again, every 3 boxes is pi over 2. Okay, so that's in the positive direction. I'm going to do the exact same thing in the negative direction. And I'm going to mark off 3 and -3. And I'll just keep one box equal to 1 on my y-axis. All right, so make sure your axes are set up just like mine. You do have to label your axes on your x-axis because we're going by radians. So if you label nothing, you will lose credit, okay? You technically don't have to label your y-axis in this instance because I'm letting one box equal 1, but if you do adjust it at all, you do have to label it. So frankly, I just always label my axes. Okay, so here's how we're going to graph sine. There's actually a quicker way to do it. If you think about how sine looks from our previous page, it looked like that, right? There's a pattern to it. You'll notice there are 3 places that we're hitting the midline: the beginning, end, and middle. So that's actually what I'm going to figure out first. So between 0 and 2 pi, I'm going to make a point here at the end at 2 pi, which is the end of one full rotation of our unit circle, and then right in the middle at pi. So go ahead and do those same 3 points. Now, halfway in between the first 2 x-intercepts, you'll notice that I'm hitting a maximum. That's at 1. So on my graph, that's at pi over 2. In this case, we're hitting a maximum of 3 because that's my amplitude. Now, between the next 2 intercepts, I'm hitting a minimum. So halfway in between these 2 purple dots right over here, I'm going to be at -3. So on my graph, that's between pi and 2 pi, so at 3 pi over 2, I want you guys to make a dot at -3. Okay, so make sure your dots, your 5 major dots here, are in the exact same places as me. As long as you then have those nice 5 dots, we're going to take pen or pencil and do a nice smooth curve connecting those. I'm going to try mine again because I couldn't see where I was going with my stylus. All right, here we go. Whee. Oh, my stylus does not want to do a nice smooth curve. Give me one more try here. It's like jumping around in there for some reason. All right, that's better. Okay, so there's my nice smooth curve. So now we just have to do the exact same thing in the other direction. Now, let's think about this for a second. If you were to think of your unit circle again, right? This is technically -pi over 2, which means this coordinate is 0, -1, which means the y value is -1. So your graph, when you continue this pattern, is going to go down, like when you look to the left, down midline, up midline. Okay, but here's the good news. It's still the same pattern. We're still going to go beginning, end, middle. So we're still going to hit the midline in the exact same places. But, like I said, you're going to hit a minimum first. So that means between -pi and 0, so like I said over here, at -pi over 2, you're going to go to -3. And then between -pi and -2 pi, you're going to go up to 3. Okay, make sure you have those points the same as me. Oop, except for I put mine in the wrong place here. I just counted wrong. There we go. There's my dot. I would have figured that out when the graph jumped a little bit too low. Okay, those are my points. Now I'm going to do a nice smooth curve to connect. And there you go. So you guys have just graphed 2 full cycles or periods of sine. So this is a cycle. Oops. This is a cycle. So we did 2 periods of 3 sine of x. 1 period is 1 full rotation around your unit circle. Now, as discussed previously, because we're moving along our x-axis here and we have no restrictions, our domain is going to be all reals. But since I adjusted the amplitude, you'll notice I'm going between -3 and 3. So that changes my range. Okay, I'm going to skip this whole maximum, minimum, intercept thing. I think that's pretty obvious. Our max is 3, our minimum's -3. And the intercepts. Actually, you know what? I'll do this. Maximum's 3, minimum's -3. I'm going to skip the intercept part. All right, cool. Now, this says a sine curve can be defined for every x in the domain of a sine curve. Sine of x equals sine of x plus 2 pi. So what does that even mean? Well, from a transformational standpoint, this means shifting to the left 2 pi units. So they're saying sine of x is the same as sine of x shifted to the left 2 pi. So ultimately what that means is if you guys take a look at this graph of sine, and I'll just pick like this portion right here. Here's 1 cycle. Oh, actually, let me do this. This 1 cycle, right? And you take that 1 cycle and you just shift it to the left 2 pi units, it would like perfectly map up. That's because 1 cycle of sine is 2 pi. That's what that's getting at. So for every shift left of 2 pi, it's going to ultimately look the same. So I'm going to write down here period or cycle. Whoops. Is 2 pi units. Okay, so that is sine with an amplitude. Okay, so y equals sine of x and y equals 3 sine of x. Now we're going to do the exact same thing, but now with cosine. Okay, here's the good news. It's still related on our unit circle. So where you guys have some space here, let's redraw our unit circle. So again, 0, this is pi over 2, pi, 3 pi over 2 until we get back to 2 pi, and these are the coordinates 1, 0, 0, 1, -1, 0, and 0, -1. If the unit circle goes cosine sine, though, instead of paying attention to the y coordinates, we're actually paying attention now to the x coordinates. So 1, 0, -1, 0. So a bunch of 1s and 0s similar to sine. Now, if you take a peek then at our graph over here, this is cosine. So at 0 radians, you're seeing 1. That's where that's coming from. At pi over 2, we're at 0. At pi, we're at -1. At 2 pi, we're at 0. And at, did I say 2 pi? At 3 pi over 2, we're at 0. And then at 2 pi, we're back at 1. And there's your 5 major points of cosine. Our domain is still going to be all reals. And our range is still -1 to 1, but the pattern looks a little bit different. So, if I pull up that same website from before, bring it on over here, okay, I'm going to click cosine. I'm just going to start my animation here. So you're seeing we're rotating around our unit circle, but they're specifically just recording the x coordinates. So 1, 0, -1, 0, 1. Here's it now with sine. I guess I should have waited until we were back at 0. Hold up, it'll restart. There we go. So you're still rotating around the unit circle, but you're just looking at different things. So they're definitely related. They're both coming from the unit circle. They're both the same y values, but they're occurring at different interval places. All right, so let's actually practice graphing this ourselves. Let me move this. Okay. So in our little table of values here, we're going to record these same numbers I was talking about. So like at 0, we have 1. At pi over 2, we have 0. At 180, we have -1. At 270, we have 0. And at 360, we have 1. These are what we're going to plot. Now, from 0 to 2 pi, same setup. Every 3 boxes is pi over 2. And I'm going to go back to every 2 boxes equals 1 unit on our y-axis. All right, now following what I have listed here, at 0 or 0 radians here, we're going to do 1. At pi over 2, we're at 0. At pi, we're at -1. At 3 pi over 2, we're at 0. And then we finish at 1. Once you have those 5 points, oops, man, I'm not great at graphing on this. There we go. My last point went a little bit too high. Then we do a nice smooth curve to connect. And that is 1 period or 1 cycle of cosine. So when we pay attention to where the graph is positive, it looks like we're positive between 0 and pi over 2, or 0 and 90 degrees, which would be quadrant 1. But then we're also positive, or above the x-axis, between 3 pi over 2 and 2 pi, or 270 and 360, which would be quadrant 4. Now again, that should make sense because based on our ASTC chart, we know cosine is positive in quadrants 1 and 4. So visually, that's why that's corresponding. It is negative, though, between pi over 2 and 3 pi over 2, which is quadrants 2 and 3. Now, as we mentioned, our domain is all reals, and our range is -1 to 1. The maximum value is 1, the minimum value is -1. So you'll notice we have the same amplitude, we have the same midline as sine of x, but like I said, different y values at different places though. Okay, as far as my intercepts go, my x-intercepts are at pi over 2 and 3 pi over 2, and my y-intercept is at 1. Amplitude's 1. Because again, that's our distance from the midline here, which is also the same as the leading coefficient on cos of x, if you notice that. And our midline is still the x-axis, or y equals 0. Oops, started to write with my highlighter. Y equals 0. So that's like right there. Okay, so that is our basics of cos of x. We're going to do one more graph. So now we're going to graph from -2 pi to 2 pi, so both directions. And I'm going to graph y equals -2 cos of x. So here's what's interesting about -2 cos of x. The 2 in front is the amplitude. Notice how I didn't say -2. Amplitude's a height, it's a distance, it has to always be positive. However, we do have a reflection in the x-axis because of that negative in front. All right, so let's start setting up our axes. Every 3 boxes is pi over 2. I'm just going to mark off 2 and -2. So I did not adjust the scale on the y-axis. I'm just going to keep it consistent with 1 box equals 1. All right, now before I get to graphing, I am going to just draw a nice little sketch of what cosine looks like off to the side here. So it starts above the midline at 1, ends above the midline. Halfway in between, we're going to be at a minimum. And then halfway, you're on the midline. So notice how I'm always breaking it into quarters, which makes sense because there's 4 quadrants. Now here's the thing. If this is y equals cos of x, okay? Normally you start at a maximum. However, remember we reflected it? So that means that instead, you're actually going to start below and then finish below like this. So this is y equals negative cos of x. So like I said, you normally start at a maximum. I'm actually going to start at a minimum this time. So that means if I'm going to graph y equals -2 cos of x, let's all start by plotting the point at -2 right here. Now, this is cyclic, so if you start at -2, that means after 1 full rotation or 2 pi radians or 360 degrees, you're going to end at that minimum. So I want you guys now to plot that point of -2 at 2 pi. So beginning and end. Now halfway in between that, you're going to be at a maximum. So that means at pi, I want you guys to plot a point at 2. So right now what I have is 2 minimums plotted and a maximum. Now the next 2 points people tend to forget, and they shouldn't because it's always going to be 5 major points, like 5 fingers on your hand. I need to go halfway between the max and min and hit the midline. So that means at pi over 2, I want you guys to plot a point on the midline, which is our x-axis. Same idea between pi and 2 pi. You got to hit the minimum again. So halfway at 3 pi over 2, you're on the midline. I almost want that to stand out more. Maybe there's like green. Okay, cool. So those are your 5 major points. I have the mins, the maxes, or max, and then my 2 midline spots. Once you have those, I like you to do a nice smooth curve to connect. All right, now I just have to repeat this exact same process, but in the negative direction. Here's the good news. Again, it's still the same pattern. Beginning, end, halfway. So you're hitting a max at -pi. But don't forget, you got to have your midline dots. So at -pi over 2 and -3 pi over 2, you're on the midline. Once you again have those 5 major points, do a nice smooth curve. And there you go. That's 2 periods or 2 cycles of -2 cosine of x. Now, a way that I remember how negative cos looks, because it starts at a minimum, is because negative cos looks like a ghost. You see my little sketch over here. Boo! Regular cos kind of just looks like a cup that you would fill with water. A sideways C, if you will. Okay, so negative cos looks like a ghost is a way that you can remember how the reflection in the x-axis looks. But you'll hear me say that probably 100 more times this unit. So like we mentioned, the domain is all reals. Our range is -1 to 1. Our maximum is 2, our minimum is -2, and I'm just going to skip the intercept part. The equation of our midline is still y equals 0. Now, the next question here, I talked about a little bit earlier. Describe cos of x as a transformation of y equals sine of x. I'm going to pull up a website to help us explain that. All right, so what you guys are seeing is sine of x and cos of x graphed together on our little website right here. So here's sine in red, which is starting on the midline, which is what you guys are seeing. Here's cos in this like purplish color, so it's starting at our maximum. So again, here they are together. Ultimately, what we've been saying is they're the same graph, but they're technically off by a horizontal shift. So let's focus on 2 points right here. Let's focus on that maximum and that maximum. What's the difference? Pi over 2, right? So how could I take my sine graph and make it look like my cosine graph, which is ultimately what that question was asking? Well, I would probably take this sine graph, which is in red, and shift it to the left, pi over 2, and it should line up, right, just to get those maximums. So let's play with how that would look. If I come over here and I want to shift left pi over 2, that means I would put plus pi over 2. Whoa. Do you guys see how those perfectly lined up? Like the purple disappeared because the red transformed right on top of it. So that's called a phase shift, which we'll talk about in coming units, but ultimately I just horizontally shifted it to the left pi over 2 units, and then they lined up. All right, so if I want to describe this transformation as a transformation of sine of x, what did I say? I said y equals sine of x plus pi over 2, and that was right. Okay, last question here. Label each of the following graphs based on the equations. So you'll notice that the only changes here I have are the amplitude. So they're all sine graphs. So the one that's the tallest has an amplitude of 2. So that would be this one right here, right? That would have to be y1. Now the one with the amplitude of 1/2, well, that would be my shortest graph. So that's got to be this green one right here. And then the one in between is your y2. So just kind of add a cute little label there with my amplitude of 1. All right, so that concludes the basics of sine, cosine, and amplitude graphing. Tomorrow's lesson is going to focus then on period and frequency. So I've already kind of pre-taught you period. Frequency will be a whole other thing.